This was a structure pop quiz 11. If you have doubt, you can mention. Question 1, any doubt, which is related to acceleration due to gravity, for how to work out practically the acceleration due to gravity. Question 2 is related to standing wave. Question 2, okay. In question 2, determine the wavelength of a wave on the string when it is vibrating as shown. So when it is producing a standing wave, so we have a node here. This is also a node. This is also a node. This is also a node, and this is also a node. What is this distance in terms of the wavelength? Because distance between the three successive nodes, that is one wavelength, and three successive, that's another wavelength. So this is one wavelength, this is another wavelength. So we can say L is equals to two wavelengths because lambda plus lambda. Or if we need the wavelength, so wavelength will be L divided by 2. So L in the question, it is 1.7. And so 1.7 divided by 2 will get the wavelength, which is 0.85 meter. The second part, calculate the speed of a wave in a string, which is having the mass is 0.2 kilogram and the mass per unit length. So if we need the speed of a wave in a string, the formula for a speed of a wave in a string is under root t divided by mu. What is t? T is a tension. How much force is there on the string? And mu is a mass per unit length. How much mass is there in a unit length? That's already given. How we work out the t? What mass is attached? A 0.2 kilogram mass is attached here. So when we write V is equals to under root T, so the mass is not the force, weight is a force. So that will be 0.2 multiplied by 0.20 multiplied by 9.81 because we got the weight, which is a force, and divided by 4.5 into 10 to the power minus 3 in a root. So we got the speed as 20.9 meters per second. So it's speed of a wave in a string. You can use this formula, or you can also use V is equals to F lambda. That will also give the same result. But we don't have the frequency or the time period. That's why we use this second one. Question 3, any doubt? Question 4. Question 5. The question 6. The Doppler's effect. No doubt in this? The other questions?